This is test 1 from the series note. Series note means, so we are starting this from the fundamentals. So I started this lesson, this test only from units and dimensions. Then the next test will be on linear motion. Likewise, then Newton laws. Likewise, I'll be covering enough units, right? So you can gain that knowledge. After that, I'll be doing mixed questions. Then that will be held every other week. So that is the program we are going to do. So this is a great program. So this is going to be very important in order to gain marks. So to gain marks, you need to have that problem solving skills, and you need to be able to solve problems within a short period of time. So you need the practice. So this test series is a great opportunity for you to gain that practice. Okay. So you need to have the consistency. You need to have the consistency. Initially, at the beginning, you are motivated, right? But as the time goes, that might wears off. Then you need to have the discipline. Then it might be hard. You won't get sometimes you won't get enough marks, your expected marks. But you need to have that brute force, okay, and enough discipline to have that consistency. So to achieve anything, you need to have the consistency. Then we'll move on to the first question. And the first question is, which option contains a fundamental SI units and an SI supplementary unit? So we have 7 fundamental units. I hope everyone knows this, right? One is meter. These are fundamentals. That is to length, measure length. Then we have seconds to measure time. Then we have kilograms to measure mass. Then we have Kelvin to measure the thermodynamic temperature, Kelvin. Then we have ampere, not coulomb, right? Ampere to measure the electric current. Then we have moles to measure the amount of substance. Then candela, this is luminous intensity. So these are the fundamental units. So this is where we start physics, right? So before you start the journey of physics, you need to have these fundamental units in order to be defined. Then using these, these are fundamental units, or we call these base units. Then we can derive for other physical quantities. Using these units, we can derive other units for other physical quantities. So there are 2 main parts, base units and derived units. Then without falling into any of these categories, there are other 2 category of units called supplementary units. Supplementary units. So those are radian and steradians. So these are the symbols, right? Rad and SR, steradian. So radian is used to measure the plane angle, and steradian is used to measure the solid angle, right? So that is a quick revision of these units. You don't need to know, you need to know all this stuff, but for this question you don't need. So what they ask is SI unit and a supplementary unit. Okay, second one, right? So we have a SI unit, Kelvin, fundamental SI unit. Another one is a radian. That is a supplementary units. Those are called supplementary units. So the answer is second one for that question. Right, second question. Option which shows the ascending order of prefixes, centi, kilo, mega and nano is. Okay, so ascending order from the smallest to the largest, right? That is ascending order. So these are prefixes. So we use prefixes in order to demonstrate some values, physical properties in a simpler way. So it looks less complicated. That's why we use prefixes. So centi, you can put this one in front of a unit. So the value of centi is 10 to the power minus 2. So instead of writing this whole thing, you can just put C. Then it looks simpler, right? We can compare things easily. That's the only reason we use this. Then we have a kilo, that is simple K, that is equal to 10 to the power 3. Then we have mega, 10 to the power 6. Then we have nano, 10 to the power minus 9. Right? So at least these values you need to know. Then if I quickly recall you, giga, 10 to the power plus 9. Right? So commonly we use this stuff. You're supposed to remember the values of these prefixes, right? When you are doing problem solving, these are going to be important. So the ascending order, so the smallest one is nano, then it is centi, then it is kilo, then it is mega. So this is the ascending order. So the nano, then the answer should be second one for that, right? These are simple questions. You just need to know these values. Then the third question, which option does not have a fundamental SI unit? Fundamental SI unit, right? So we discussed 7 fundamental units at the previous question as well, at a previous question. So ampere is a fundamental unit, right? Ampere is a fundamental unit. Why is that? It looks like a derivative unit, but by definition, the electric current that measured by amperes is made a fundamental unit by definition, right? Electric charge is not a fundamental unit, but electric current is made fundamental unit. They have checked this many times, right? Because students confuse that or might forget that ampere looks like a derivative unit. It is not. It's a fundamental unit. Then Kelvin, kilogram, and mole, those are obviously fundamental units. And volts, that is, volts is not a fundamental unit. Volts is used to measure the potential difference. You will learn this stuff when you are doing electric fields and electric current electricity. You will oftentimes you will be using volts, but I'll just say what a 1 volt is, right? 1 volt is actually by definition joules per coulomb. So that 1 volt is like something like energy, right? Related to energy. That's why joules there. So energy per unit charge, unit electric charge. For now, just remember like that, right? So this is not a fundamental unit. This is a derivative unit. Or else everyone knows this equation. So from this one, this is the fundamental unit. Then multiply by ohms. So obviously volts should be a derivative unit. You will learn this extensively when you are doing current electricity, right? Okay. So the answer is fifth one for the third question. Fifth one for the third question. Right. Then fourth one, value of gravitational acceleration is 9.8 meters per square second. Numerical value of it, kilometers per square minutes is. So many students have found this somewhat difficult, but this is a simple unit conversion, right? So any units, those who don't know, any units can be converted by the method I'm going to teach you now. So I'll write this one like per square centimeter. I can write it like this, right, as the denominator. So you need kilometers. So you know this is 9.8 times 1 meter. So what is a 1 meter? 1 meter is kilometer divided by 1000. So in order to get a 1 meter, you need to divide 1 kilometer by 1000. 1,000th of a kilometer is a 1 meter. Another one is you need minutes. So 1 second is what? 1/60th of a minute. 1/60th of a minute. Got it? Then with the units, just substitute the values here. So 9.8, 1 meter means 1 over 1 kilometer over 1000 divided by S, that is 1 over 60. Substitute with the whole unit, right? 1 over 60 minutes. What do you get? So 9.8, 1 over 1000 means 10 to the power minus 3. I can write this as minus 3. This is 160 squared. As it goes to the numerator, it flips and becomes 60 squares, right? Then you have kilometers here at the numerator, and here at the denominator you have minute squared. So per squared minutes, kilometers. Now it is converted. Then you just have to simplify this. Okay, 9.8. This is 6 squared means 36. You get 100 from here, then minus 1. I'm explaining simplifications as well because some students follow longer methods to do simplifications, right? It is one of the way you waste time. So you need to follow the correct simplifications method as well. You need to be able to quickly get the answer, right? Right, then we need to multiply 98 by 36. If you like multiply by 10 to the power minus 1, this is going to be 3.6, right? So this is the calculation we need. So 98, 36, 48, 54, 58, 24, 29, 8, 12, 15, 30. So what you get is 35.28. So there are 2 decimals. So you need to place 2 decimals from the right. Okay, so we get this answer. There's a bit of simplifications, right? You need to practice simplifications, right? Many students just don't do these simplifications whenever they see a complicated simplification, but in the exam you get these simplifications, so you need to get used to these. Okay, so the answer is they have rounded off. I think it is 35.3 kilometers per square minute. They have rounded off 35.3 kilometers per square seconds. So the answer should be 4th one for that question. Okay, so in this method, if you practice this method, you can convert any unit. See there? There's just a substitution instead of the unit you need. Instead of meter, I just put kilometer divided by 1000. Just substitute with the units. That's all you have to do. Right. Then at the fifth question. If pressure of air is P and volume is V, units of PV can be. Okay. So what is the unit of pressure? In O levels, you know this. If you have learned hydrostatics, now you know this very well, right? Pressure. But in O level as well, you know the units of pressure. That is newtons per square meter. Because pressure is force divided by area. Force Newton, area is square meters. So if you divide it, you get newtons per square meter for pressure. Then volume is obviously cubic meters. So if you multiply this, what do you get? Newton per square meter, cubic meters, plus 3 minus 2 plus 1. Newton meter. So what is Newton meter? This is joules, right? I think everyone have learned energy by now, work and energy. So the unit to measure that energy is joules. Okay, so the unit answer should be 4th one. Right. 6th question. Energy of a photon is given by E equals hf. H is Planck constant. So what they ask is possible units of H, Planck's constant. You will need this question when you are learning matter and radiations, right? So that is the last lesson of the syllabus. So we'll be using this many times, often in that lesson. So here you just have to know the units there. Planck's constant. I think in chemistry you learn this, right? Okay. So energy is measured in joules. You have the Planck constant. F is per second. So just take this to the other side. Joules per second equals H unit. Per second goes to the numerator, it becomes plus joules second. So joules second is the units of Planck constants. In that way you can find it, right? So there are values for this Planck's constant. This is in order 10 to the power minus 34 something joules second, right? You will learn this in matter and radiation. Okay. Then 7th question, let's try that. Displacement of an object moving at constant acceleration a within time t is given by s equals kat squared, let's say. S equals kat squared. So what they ask is the dimensions of k. So whenever you get a question to find dimensions, you know that left and right side of an equation has the same dimensions, right? So you can write like this. This is dimension. The s dimensions has kat squared dimensions. Okay. So s is a distance, so dimensions L. We have k dimensions. We don't know that. A is acceleration. Lt minus 2. ms minus 2 times t squared means time squared. And t squared minus 2 cancels off. You have L cancels off from the both sides. So the another important thing, you need to cancel everything off that can be cancelled, right? If something can be cancelled from sides, you need to get rid of that. You need to have, don't keep even a single thing when you're simplifying, right? You need to cancel everything that you can cancel. Then the simplifications becomes easier. So those are the mistakes that students make. If there's something to be cancelled, you need to cancel that, right? Okay, so now everything is cancelled off. So the dimensions of k is 1. What does it mean? K is dimensionless, right? K is dimensionless. That's what it means. So the answer is 5th one for that question. Question number 8. Velocity of sound in gas at pressure P, density rho is given by V equals Kp divided by rho. So this equation you learn in velocity of sound. You learn in waves and oscillations, right? You will learn that. So this is Kp, pressure divided by rho. So what they ask is dimensions of K. So if you already know this unit, at once you can say that K is dimensionless. This K is actually a dimensionless constant called gamma, right? Gamma. So once you see the equation, you know that K does not have dimensions. But since up to now you haven't learned this, we need to do the usual calculations. So I'll just square both sides. Kp divided by rho. I'll subject K. Cross multiply V squared rho divided by P. This is K. Then I can take the dimensions of both sides. So V squared Lt minus 1. So when you square it, L squared T minus 2. Rho means density. So that is mass divided by volume. Mass divided by volume. L cube. So this is ml minus 3. Pressure. So pressure is what? Force divided by area. Force is ml T minus 2 divided by area. L squared. So what do you get? ml squared minus 1. Plus 2 goes up. 1 minus 2, it becomes 1 minus 2. So what you get? L minus 1, T minus 2, L minus 1, T minus 2. Okay, so cancels off. Then you get L minus 1, it cancels off with this L minus 1, T minus 2, T minus 2 cancels off, like everything cancels off. What you get is 1, right? So what does it mean? Means K does not have dimensions. It is dimensionless, right? It is actually a ratio. That K value is a ratio. So it does not have any dimensions. Right, moving to the next one, 9th question. Surface tension, capital T, is defined the tangential force per unit length of a liquid surface. Dimensions of surface tension is. So surface tension you learn in properties of matter. That's the 10th unit, right? But here they have already defined what surface tension is. So you can figure it out. So according to what they say, surface tension, there's something called, this is a property of materials actually, surface tension. Liquid surfaces. You don't need to know all those. But here surface tension, there is a force per unit length. So per unit length means you need to divide by the length. So what they ask is dimensions of surface tension. So what's the dimensions of force? ml T minus 2 divided by length. So what do you get? LL cancels off mt minus 1. This is the dimensions of surface tension, mt minus 2. Okay. So the key point here is when they say per unit length, what does it mean? You always have to divide it. Let's say per unit time, you need to divide by time. If they say per unit length, you need to divide by length. Okay. So other one is a per unit volume, you need to divide by volume. So the answer is 4th one. Right, then 10th question. Viscous force acting on a small sphere with radius a and speed v is given by F equals 6π a eta v. This is also in properties of matter, right? But you can do a dimensional analysis using only what you know. So what they ask is dimensions of eta. So both sides have the same dimensions. So the dimensions of a force is ml t minus 2. 6π, it is just a number, doesn't have dimensions. Simple a, it is a radius, right? So it is a length. Eta dimensions is what we need. Then dimensions of velocity, that is lt minus 1. Okay. Then just simplify in order to find dimensions of eta. L cancels off. Here we have m. T minus 1 cancels off with a 1 t minus 1. Then this L comes to the other side, ml minus 1, t minus 1. So that is the dimensions of eta. Okay, ml minus 1, t minus 1. We have an answer for that. ml, there's a problem with the answers, right? So the answer should be ml minus 1, t minus 1. So you will be given all to that question. All to that question, right? There's no answer in the questions. ml minus 1, t minus 1, no answer, right? Or do we have an answer? There's answer. Sorry, there's answer. 10th question, right? I was mixed up with the previous one. Third answer, ml minus 1, t minus 1. So the answer is third one, right? 11th question. The physical quantity with dimensions ml square t minus 3. So they have given the dimensions and they are asking about so what is the dimensions? ml squared t minus 3. So here what they ask is what could be the physical quantity. So it is obvious force is ml t minus 2, first one, not first one. So you have to get rid of each one. Force does not have. Pressure also does not have, because ml t minus 2 divided by L squared, that is ml minus 1 t minus 2. So it is not, right? Pressure does not have. Work. So what is work? Work is force times distance. So it is ml t minus 2 times L, force times distance. So it is ml squared t minus 2, not the same units, dimensions. Density obviously does not have, so the answer should be power. So if I recall you, power is work divided by time, right? So work is this one, ml squared t minus 2 divided by time, that is t. When it goes up, minus 1 minus 2. So it is ml squared t minus 3. So the power has these dimensions. Okay, power ml squared t minus 3. Right. Then 12th question, gravitational force F between two masses. Let's say these are the two masses. Then there's a gravitational force. This is actually mutual gravitational force. You will learn this in gravitational fields, when you learn gravitational fields. And the distance between these masses is simple r. What do they ask? Then you can quantify this force. Whenever there are two masses, there's a interactive force between those two. So that is how the planets and all those are held together, right? So this we can quantify that using this, okay, this equation. So what they ask is dimensions or units, dimensions of G. So subject G, fr squared divided by cross multiply m1 m2. So both sides should have the same dimensions. Force dimensions ml t minus 2. R is a length squared, mass capital M, so this becomes m squared. So dimensions of G, m squared goes up, plus 1 minus 2 m minus 1. You have L cube, plus 1 plus 3 L cube t minus 2. So this is the dimensions of G, capital G. We call this universal gravitational constant. We will learn this. This is called universal gravitational constant, right? But you, in order to get the answer, you don't need to know that. Okay, so the dimensions m minus 1 L cube t minus 2. First one, right? So the first one is the answer, right? 13th question. In the equation V I K J S, V is velocity, S acceleration, S is displacement, K dimensionless constant. So what they ask is values of I and J. So the equation is V I K. I'm not writing K, right, because dimensionless, we don't need that. A J S. S is displacement, A is acceleration. So for this equation as well, if it is a correct equation, both sides should have the same dimensions. Then we'll do just substitute dimensions. So velocity, dimensions ml lt minus 1, simple I. Acceleration lt minus 2, j to the power j. S means L, it doesn't have a letter, but value here is 1. What do we have? Just multiply Li t minus I. So we have here j L j t minus 2j. Clearly write j, right? Don't write j like simple I, right? You need to have this hook. Write this hook clearly. Otherwise you will have a mix that with simple I. So Lj t minus 2j L1. I'll further simplify this. So L we have. So it becomes L j plus 1. j plus 1, t minus 2j. Okay, then compare both these two. Just think about L. If you think about L, this L, what do you see? This power is equal to this power. So you can write this equation, I equals j plus 1. Then think about T. So this power is equal to this power. According to that, I is equal to minus 2j. Minus I, right? Minus I. Then just multiply both sides by I. So I is equal to 2j. So we have these equations. One equation, two equation. Then you just have to simplify these simultaneous equations to find I and j. Okay, just try to do it in a simpler way. So I is equal to 2j. So instead of this I can put 2j there. 2j equals j plus 1. Take j to the other side. This becomes 2j minus j. J equals 1. Okay, now we have value for j. Then just substitute it here. So I is equal to what? 2j. 2 times 1. So that is 2. Okay. So values I is 2, 2 and 1. Third one is the answer there, right? 13th. So whenever you have a equation, both sides have the same dimensions. So that is the theory we used here, right? 14th question. A sound wave with frequency f, amplitude simple a, moves in a medium with density rho. Correct equations that represents energy per unit volume. So this E is not just energy, right? This is what? Energy per unit volume. What does it mean? Energy is divided by volume. Correct? It's not just energy, right? Whenever say per unit volume, it should be divided by volume. So what they ask is which one? So we have given 3 ABC options. Then they ask which one has the which one measures the same thing, energy per unit volume, from these equations. So before doing that, you need to know what these clearly. In waves and oscillations, you will learn this extensively, right? But here in O levels as well, you learn this. Okay, what is frequency? That is 1 over t, 1 over time period. Okay, 1 over t. So dimensions of frequency should be 1 over capital T. So that is t minus 1. That's the dimensions of frequency. Then this amplitude. Remember what amplitude is? In a wave, the height to the maximum point is what we call amplitude. So that is a length. So A has dimensions capital L. Then we have rho. Rho you know somewhat, right? That is mass divided by volume. So it should be ml minus 3. Okay, so those are the quantities. Here let's derive the dimensions of E. So energy, we know normal question is work, right? Energy and work has the same dimensions. They are the same kind of similar things, right? So energy also has Fs. Dimensions of F is ml t minus 2. S is L. So you get ml square t minus 2. So energy has ml square t minus 2 as dimensions. Then you need to divide that by volume, L cube. So this becomes ml minus 1 t minus 2. So that is the dimensions of energy. Not energy, I mean energy per unit volume. We get these dimensions. Then now we know all the physical properties here. Then we need to get we have given A, B and C options. So what they ask is which one could have the correct equation. Let's check A. So A has rho A F squared, right? So rho, dimensions of rho ml minus 3, amplitude L, frequency t minus 1 is squared, t minus 2. So ml minus 2, t minus 2. This is the dimensions of this equation. Does it match with this one? No, right? So option A is not a correct equation. Then we'll move on to B. Here we have rho A squared F squared. Let's check whether it has dimensions of E. E means energy per unit volume. Right. Rho is ml minus 3. This is length. Length is squared. T minus 1 is squared. T minus 2. So we have ml minus 3 plus 2 minus 1. T minus 2. ml minus 1. T minus 2. Okay. Those two match. Correct. So that is the B is a correct equation. Then we'll move on to C. Here we have a dimensionless constant, right? Rho A squared F squared. If you check these two equations, they are the same equation. The only difference is it is multiplied by a K. K is a dimensionless constant. What does it mean? It means the dimensions does not change if you multiply by a K, right? So this equation also can be considered to be true. So the answer should be B and C, fifth one. B and C, fifth one. Right. 15th question. Rate of mass leak in through a small punch in a gas cylinder is simple M. This is simple M, right? This is not just mass. This is a mass flow rate. So mass divided by time, right? So this has dimensions mt minus 1. Not just capital M. You need to be careful of those. Even though they say that is just simple M, but they have defined that to be a mass rate. Right? So M is mt minus 1. Or in units, it could be kilograms per second. Right? Kilograms per second. That is a unit for mass flow rate. Then they say that you gain that by this equation. K is dimensionless, right? So I'm not writing K. You don't need to write. But in a essay question, it's better to write K. Here P alpha, rho beta, A gamma. What do we have? Both sides need to have the same dimensions. So dimensions of M, that is mt minus 1. Then dimensions of pressure. Many times we now found dimensions of pressure, right? Force divided by area. So it is ml minus 1 t minus 2. If you don't remember, just substitute, right? Force divided by area is the pressure. Alpha. Density is mass divided by volume, so it should be ml minus 3. Beta. A is area. Is it area? Yeah, that is the area of the punch. Area means L squared, gamma, right? So here you have M1, T minus 1. Since we don't have a L here, capital L, I'll just put L naught, L to the power 0. What is it? It is 1, right? Nothing changes when you multiply something by 1. Okay. So I'll just put L naught here. Then you need to further simplify these. first I'll simplify capital M. What do we have? M alpha. You need to carefully do this, right? One mistake, you get a completely different answer, right? You need to carefully do this simplification. So we have M alpha. Then has M beta. What is that? Alpha. When you multiply M alpha plus beta, then we'll simplify L. L minus alpha. Here you have minus 3 beta. Then have the 2 gamma. 2 gamma. Okay, so that is a simplification of L. Then you have T time. That is minus 2 alpha. Yeah, that's all. So this calculation you need to do carefully. Right. Then think about mass terms, capital M terms. So we have powers. Compare the powers. 1 equals alpha plus beta. So we have one equation. Then I can go for time, right? T. We have minus 1 equals time. Where's that? Minus 2 alpha. Okay, so from this equation you can find alpha actually. So minus minus it becomes plus. Then alpha is what? Already you know the value for alpha. That is half. Okay. If you can find, just simplify that. Right. So if you know alpha, you can substitute it here and find beta. So beta what is? 1 minus half. That is half. So beta is half, alpha is half. Right. There's one more value we need to find. That is gamma. Right. So to know gamma, to calculate gamma, we are going to use this one as well. So for that, compare the powers of L. Right. Here you have a L naught, L0. Here you have minus alpha, minus 3 beta, plus 2 gamma. So minus alpha, what is that? Alpha is half, minus alpha, minus half. Beta is half, right? So minus 3 beta means minus 3 over 2 plus 2 gamma. 0 equals, this is the denominator, minus 1, minus 3, minus 4 divided by 2 plus 2 gamma. So this is minus 2. So 0 equals minus 2 plus 2 gamma. Minus 2 goes to the other side. Becomes 2. So 2 equals 2 gamma. What is it? Just divide by 2. So gamma is equal to 1. So what are the values? Alpha is half. Beta is half. Gamma is 1. So these are the alpha, beta and gamma values. When you are doing simplifications, these power simplifications of these powers, right? And then there are simultaneous equations as well. You need to be careful, otherwise you will get a completely different answer, right? One mistake, right? If you make a one mistake, you will get a completely different answer, right? So the answer for that should be third one, right? For the 15th question.